Hello class, welcome to Conversation with Ming. Today's conversation will be with Mr. Alan Mendonça. We are going to discuss case study 1-4, Supporting Mobile Health Clinic on page 157 through 165. The conversation will be aired in two parts. In the first part, we will cover the information technology implementation and management, which are summarized into 5 technology characteristics shown on the next slide. In part 2, we will focus in data security for healthcare IT, especially HIPAA and PHI. Healthcare information security and audit will be posted for chapter 14.
The first question I have is for IT remote support. For an MMC implementation, how is IT support different from a normal healthcare IT implementation?
Conceptually, MMC is the equivalent of a mobile clinic. The most important aspects for managing such an infrastructure is standardization and dedicated devices. When I talk about standardization, I'm talking about product that is deployed on the device, that is locked down, and we have consistent knowledge of our ability to support it. The other aspect that's most crucial is our ability to remotely manage it in case we come across an issue. Typically in a Microsoft environment, we do this through the remote desktop. In tablets, because we have them locked down, remote management is going to be a new art, since these have become more prevalent in the healthcare space in only the last year or so.
My second question is about usability. Along with ease of support, ease of use is another characteristic of MMC. Can you elaborate this point?
So typically in a modern electronic health record system, when the system is deployed, all users are trained for their specific roles. So there are classroom sessions that get the user familiar with the user interface, get them familiar with the workflows, and get them familiar with the expectations of the system. And what I mean about expectations of the system is the system manages a certain level of integrity of the data. If it is not met, typically these things are tracked in error work queues where someone has to resolve these errors so that we have a complete transaction and a complete patient profile that is created on the system. So when we talk about ease of use today, the important thing is consistency. The system works in a consistent fashion, in a consistent workflow. So once the end users are comfortable with it, they have an existing expectation of what the system will deliver.
So, ease of use does not mean that it is so easy anybody can do it, but ease of use means usability and learnability of the systems via tools and training.
Clearly, end user training is very important. The new healthcare systems are complex and far-reaching. Essentially, they are a fully integrated system. A doctor enters information at one point and it's completely available to everybody else. So it's important that they understand the implications of what they're doing and that the system maintains that integrated level of information sharing. The challenges with a mobile clinic is our ability to connect to it from a centralized system. Design the network. It's important that we build in redundancy. And what I mean about redundancy is it's insufficient to have a single connection to the network. we want dual connections, so if one fails, we have the ability to piggyback onto the second one. And then, of course, we talk about the centralized environment where we have redundancy on the servers. So if there's so we eliminate single points of failure. Reliability is viewed as what product are you using, what is its track record of reliability, and what is its track record of performance. A lot of products today meet these requirements. If we choose a niche product, then with it comes some level of testing and trial which is not suitable for mobile deployment. So today we have two methods of mobile communication. We have the emerging and relatively widely used 4G long-term evolution product that is provided by companies such as Verizon and AT&T. Connectivity is relatively straightforward. We would have a device that connects to the network. In terms of the traditional network, we have a service provider, an internet service provider, that provides you a certain level of bandwidth. Typically it's over a T1 line. Then alternatives are also sold by services such as Verizon, Google, and AT&T. They provide fiber networks to organizations which have larger bandwidths. Of course, the new emerging standard is Google's 100 gigabit network. These are in the early deployment stages. The city of Kansas is in a joint venture with Google to provide networking, free networking through the city, and commercial enterprise networking that has high bandwidth and high level of reliability. This, of course, plays directly into the new media that's going to come in with electronic health records. So we will have complex multimedia implementations, things like x-rays, monitoring at the bedside, collection of data that is far more complex and requires greater bandwidth to serve at remote units.
To go from the MMC unit to the main data center.
Yeah, so today the MMC will be somewhat challenged in terms of multimedia bandwidth. So the best approach that is provided today is the analysis is done centrally in the hospital and posted onto the patient chart by specialists. That information is available to someone that's looking at a patient chart to deliver treatment to the patient. So we have ease of access and availability of patient information. It may not be full-fledged multimedia capability, but that would be the next step as mobile networks evolve. If we want to achieve a higher level of bandwidth, it would require that these mobile units be at a point where they can jump onto a T1 or fiber bandwidth service, which would pretty much be unlikely in underserved areas, since that's why they're called underserved areas.
So when we talk about multimedia, we are really talking about X-ray, ultrasound, and those types of medical records, right?
We would have, for example, for an expectant mother, we would have an ultrasound that is really a video of the ultrasound, and that provides both the physician and the parents the ability to see what's going on. In terms of X-ray devices, these are large format data, and the ease of transmitting the actual content becomes more difficult. Current solutions require that we use solutions such as Citrix, where we handle the presentation centrally and only pass across the screen scrape to the end user device. So this means that we minimize the large flow of data across the network and maintain the availability of the bandwidth.
Right, about the use of satellites communications for this kind of implementation?
Current satellite communication is somewhat limited in bandwidth. It can be used as a backup where we do not have the need for fairly complex data to be presented. The challenge there is the bandwidth is the issue, and the big asset there is we would have communication access with the central site, no matter how remote we are, with the understanding that we're not going to have the same level of performance of all the data.
In regards to privacy and healthcare protection in IT, we will have a full conversation in regards to HIPAA and PHI, but can you just give us a high level of what they are?
Certainly, HIPAA is the Health Information Portability and Accountability Act. It defines a certain level of audit and tracking of information on the healthcare record. PHI references protected health information. The only people that would have access to these protected health information portions are people who are actually delivering patient care. So if there is no need for them to see the record, they are restricted from seeing protected healthcare information.